Okay, here we want to look at two more examples of how to find the domain of functions. Okay, so now, first, when we look at the top one, f of x is equal to 8x plus 3 divided by x squared minus 4x minus 12. We have to find the place where the function can exist. Now, one thing that we know, we can never have a 0 in the denominator. So we have to find this. We know that x squared minus 4x minus 12, this cannot be equal to 0. All right. So what do we need to do? We need to factor this. This is going to give us x minus 6 and x plus 2. Neither one of these could be equal to 0. And we just slowly break it down. So x cannot be equal to 6, and x cannot be equal to negative 2. Any other x values will make this function okay. As soon as we plug in a 6, or as soon as we plug in a negative 2, that makes our function undefined. All other numbers work. Now, how do we put this into interval notation? We're going to say negative infinity to negative 2. All right. We can put any number in from negative infinity up to negative 2. The negative 2 is not included. Any number from negative 2 up to 6, which means negative 1, 0, 1, 2, 3, 4, and 5. All of those numbers will work fine. And then numbers from 6 to infinity. So this domain would be all the real numbers except for 6 and negative 2. All right. So now let's come down below and look at this next one. It's the square root of x squared plus 2x minus 5. We know that we cannot have a negative up under that radical. So what do we need to do? We know that x squared plus 2x minus 15, that has to be what? Greater than or equal to 0. So look closely. This is how we're going to set this up. Of course, we have to factor what numbers could add to give us a 2. But if we multiply, give us a negative 15, that would be x plus 5 and x minus 3. So this is what we want to do. We want to put these on a number line. Negative 5 and positive 3. Because of course, after we solve this, we would have to choose the opposites. So this is what we do. Let's choose any number less than negative 5 and plug it in. Just say negative 7. Negative 7 plus 5 would be negative 2. Negative 7 minus 3 would be negative 10. Negative and negative would make that positive. That's fine because here we knew that it had to be what? Greater than or equal to 0. That's fine. Let's look at any number between negative 5 and 3. Let's choose something simple. Let's choose 0. 0 plus 5 is 5. 0 minus 3 is negative 3. Positive times negative, that would give us a negative. Okay? And now let's choose any number on the other interval which is larger than 3. Let's choose 4. 4 plus 5, we're looking here. 4 plus 5 will give us positive 9. 4 minus 3 will give us 1. 9 times 1, that's 9. That's positive. So we've already established the fact that everything in our these numbers in our domain had to be greater than 0. So how do we write this in interval notation? That's going to be negative infinity up to -5. And we're going to put brackets around it because, remember, it can be 0. So we'll put the brackets around the -5. Union 3 up to infinity. This part, all the numbers between -5 and 3 will not work because those numbers would give us what? A negative up under the radical. Those will give us a negative number, and we know that we cannot have a negative under the radical. So this is our domain from negative infinity up to -5, and also from 3 to infinity.